Good afternoon, ladies and gentlemen. Thank you for joining us. Thank you for your patience, and welcome to this afternoon's masterclass series in the SOCAA-SheTrades ITC-SheTrades partnership, where we're looking at the avocado, French bean, and peas value chains. My name is Ricky Aguda. I serve as the CEO for the Secretariat of the Society of Crop Agribusiness Advisors, and we are partnering on this particular masterclass with ITC SheTrades Commonwealth Program, which is a program designed to empower small and medium enterprises, especially those that are women-led, in order to facilitate greater market access and also sustainability in their businesses. SOCAA is a network, membership-based organization that brings together crop agribusiness advisors who cover different aspects of advisory work, all the way from inputs to market access. And this particular partnership is aimed at putting members of SheTrades and other interested parties in agribusiness in touch with our diverse pool of experts who cover a range of topics. We have this afternoon two very experienced experts with us, and we will be covering the topic of optimizing production and market access for peas with reference to sugar snap, snow peas, and garden peas. And this is looking at both the issues of production, which will be covered in depth, and maybe as a carryover from our last session on optimizing market access for French beans, we may have some specific questions on the peas value chain. We encourage you to introduce yourself even as we begin using the chat box. Please let us know who you are and where you're engaged in the value chain. I know quite a few of us have registered before, but it's also good for interaction with each other to do introductions and using the chat box. We'll also be sharing a link for a survey that has been ongoing through this series, just to give us some feedback so that we can improve on the topics or issues of covered and make the series as responsive as possible. So please let us know what particular issues you may have with regards to today's topic, or generally as far as this webinar masterclass is concerned. In the next series, we'll be looking at avocado. I know quite a few of us have been asking, when will we be covering avocado? But as we are drawing to a close on peas and having covered French beans, the next value chain we'll be looking at is the avocado value chain. For now, I would just like to give the panelists who are already on board an opportunity just to do a quick introduction. I do apologize, one of our panelists is still having a bit of a challenge getting on board. That is David Ndegwa, but he's about to join us shortly. We have on board Apollo War, who was with us last week, and probably I'll just allow Apollo to do a quick introduction, even as we continue introducing ourselves in the chat box, and please also making use of the link for the survey and taking a few minutes to put in that information. So thank you very much for joining us, and thank you for your patience. Apollo, if you're able to introduce yourself.
Thank you. Ladies and gentlemen, Apollo Ward. I am the chairman of Fresh Produce Association of Kenya, an agripreneur involved in horticulture farming, and I'm also work within what is called Coliform as a board member. I'm very excited to be here this afternoon in order to share learnings and experiences on within this value chain, and would be glad to contribute and take questions at the end of this Ndegwa's presentation. Thank you very much.
Thanks, Apollo. You will definitely have to raise your volume a bit more, but thanks for joining us. And I'm sure quite a few of our participants are keen to engage you when we get to that particular session. We'll have a brief introduction from David Ndegwa, who's now joined us as well. David, Karibu, just say a brief hello and we'll get started. David, we can't hear you. I think your microphone is still off.
Can you hear me now?
Yes, we can.
Oh, yes. Good afternoon, Ricky. Hello?
Yes, David, please go ahead.
Hello? Yeah, my name is David. I'm a farmer. Let me say I'm a farmer or a grower. And I currently am growing crops in a farm. We have a farm in Arumoro, Gazi Limited, and I'm the managing director. I've been in this horticultural field for the last 25 years. And the subject matter that you're going to talk about, this is a crop of peas. This is a crop that I've done for like 18 years of my growing career. Thank you.
Thank you, David, for that brief overview. So before we get into the presentations, and David will be starting us off with the presentations. But just to give us a brief again in terms of the background of the cooperation, this particular webinar series is brought to us through a collaboration between the ITC SheTrades Commonwealth Program, which is focused on empowering women-owned businesses in order to ensure increased trading and sustainability of their businesses. In partnership with SOCAA, which is an association business member organization for crop agribusiness advisors. We've shared through the registration and given all our participants room to share on their expectations, and we know that there is quite a bit in terms of how can we improve market access for these commodities, how can we get into new markets, what are the opportunities for value addition, but also how can we be more competitive in our production. And the experts we have on board today will help us to address both of those issues. Of course, first of all, starting from the basics, which is understanding what it is you need to do in order to ensure that you optimize your production for peas, be it sugar snap or the snow peas or the garden peas. And then, of course, when it comes to the market opportunities, which we did cover quite extensively last week, we'll be having a recap based on the questions you raised on what needs to be done in order to ensure that you have maximum value from the sale of peas, be it in the domestic, regional, or export markets. So that said, I'm going to request David to proceed with his presentation in this first segment. And as David is making his presentation, again, please feel free to share any questions or comments you may have using the chat box or the Q&A box. Welcome, David. David, I believe you can now share your screen. Yes, David, you can. I think you can proceed and share your screen. We see you in the greenhouse today.
Yes, I'm in the field. I hope I'm audible enough.
Very audible.
I want to share my screen. Getting some challenge here.
David, are you able to share your screen or?
I'm trying to share, and it's giving me some challenges. Hello, hello.
Yes, David. We're just waiting for your screen to come up.
Yeah, I'm trying to. I'm going to sharing and it's not responding.
You want to maybe email, if you could just email it across and we can put it up from this end.
Yeah, let me email it.
Yeah, but you could make a small introduction or as you do that. Yeah, sorry.
Yeah.
Apologies to our participants for this technical hitch, but I think we are moving on.
So today we are going to talk about snow peas. And as I work on sharing my screen, I would like to introduce the crop. Mainly, we are talking about peas in general, and there are quite a number of strains or species of peas that are grown. We have sugar snaps. We have there are actually types of peas varieties, and this is the snow peas, sugar snaps, and garden peas. Those are the main crops that are grown, or main varieties that are, or main types that are grown in the field when it comes to commercial and mainly for export. But there are other types that are also grown for local consumption, and these are normally called grano and the likes. So today I'm going to limit my discussion to snow peas and sugar snaps, and to some extent garden peas. So last week, if you remember, our viewers, we had a session on fine beans, and we were discussing about how to grow fine beans effectively. So today we are going to be talking about how to grow sugar snaps, snow peas, and garden peas effectively. And starting from the bottom, or from the base, if you want to grow garden peas or snow peas or sugar snaps successfully, you use the same parameters as we discussed on on fine beans. One thing that you have to ensure that you are taking care of is to ensure that you have checked your soil, the soil type, that is the structure, and in the structure you are looking at workability of the soil and the drainage. You do not want to be growing in a place whereby the soil will be very unfriendly. The soil should be able to drain, the drainability, and also you don't want to be growing in very heavy clay soil that will become waterlogged when it rains. Then you also check on the nutrition. The structure you can check through observation, and the other text that you can be able to do when you're in the field. For the nutrition, you have to do soil sampling and take your soil for soil analysis. The reason as to why you have to take your soil for analysis is because you want to know what nutrients are in your soil, so that if you are to make any adjustment, you you supplement using fertilizers based on what the crop requires. Mainly,
David.
we use a system. Yeah.
Maybe you could
Ricky,
just
can you hear
put
me?
your video on as you. Yes, could you just share your video as you continue? And I'm hoping you managed to email your presentation across.
I don't think I'm good in multitasking. So can I let me share then?
No, but if you okay. But you could just put your video on, David. Sorry.
Oh, it's off. Seems there are so many problems in the field.
Yeah, we understand the nature of the challenges. Yeah, but I think your video.
Yeah, I've gotten it. Now you can see me. My video should be on now.
Not yet, David.
Well, this is tough.
I think, David, you just proceed in the interest of time. We'll sort out at least we'll be able to share the presentation after this. But yeah, let's proceed so that the listeners can follow your expose.
Sorry for that. I hope the listeners will be able to listen to my voice. Now, in the soil, we are talking about the soil analysis and the reason as to why we do have to do the soil analysis. And I was explaining how you do the soil analysis. When you reach the field, depending on the area, if let's say, for example, you've got like 5 acres of land, you need to select a representative field among that. You take an acre, and then you do like a W shaped, and you take 25 samples collected from the depth of 20 centimeters of your soil, and you take that for soil analysis. Once you collect 25 samples, you combine all the samples, you mix them together properly to homogeneity, and then you pick a kilo or half a kilo. That is the soil that you take for lab analysis. Within that lab analysis, you'll be able to get the nutrients, the content of nutrients that is in your soil. Based on that and the crop that you want to grow, you will be able to, if you get any agronomist, he will be able to advise on the fertilizer program that you need to use. On that parameter, still in the things that you need to consider before you select the best site for your garden piece or for your peas crop. You also have to analyze whether you have adequate water, and this way you can have the borehole water. You could either use a dam or river water. Once you identify your source of water, depending on the pocket and the site that you have selected, then you also have to take your water for analysis in order to ensure that it is suitable for irrigation. And mainly you'll be looking for, if the coliforms are higher, counts are higher in your water, then that water may not be suitable for irrigation because of the health and safety issue. Then you also have to look at most of the horticultural crops are labor intensive. You need to ensure that the area that you are working on, you'll be able to get adequate labor, especially when you're harvesting, because the demand for labor can actually put you down when it comes to harvesting and doing other farm-related practices. The altitude at which you need to be setting your farm within when you're growing peas, they should range between 1,800 meters above sea level to up to 2,400. That area would be adequate for your crop of peas. And then once you do the soil analysis, you get a good agronomist who will work out a good fertilizer program for your crop. Then you'll be able to run. Today we are going to look at the factors of production. As you know, these factors of production, we want to be competitive when it comes to production. And one thing that can make us become competitive is if we manage to reduce our cost per kilo. And how do you reduce the cost per kilo? You reduce the cost per kilo not by cutting the necessary inputs that are required, especially the fertilizer. Once you work out the fertilizer that is required, you don't need to scale it down. You need to ensure that you optimize your fertilizer, chemicals, and everything. If I say optimization, there's a difference between optimizing and maximizing. You could be the fertilizer, for example, has a level at which if you apply more, then you don't realize further benefits as a result of adding that fertilizer. This is the point of optimal. And this is what your agronomist will be trying to advise you on to ensure that when it comes to nitrogen, potassium, and phosphate, you're not, and phosphorus, you're not going above the limits that would hit into your pocket. So the moment you get what you need in terms of inputs, you have to ensure that you use them judiciously so as not to hit on your pockets, but also not to compromise on your production. So you reduce the cost of production by increasing your production, because the cost of production per kilo is found by dividing the total cost of producing and the yields. So if you have a higher figure in terms of yields, let's say, for example, if your cost is 200,000, as I'm going to demonstrate here, and your production is 4 tons, your cost per kilo would be less than from that farmer who produced 3 tons. So our aim would be about producing more per unit area rather than less per unit area, and that's how we will increase our competitiveness, because price may vary, price may go up or down, but what comes into our pocket is dictated by the kind of production that we get. So that's very, very important. So today we are going to look at the 4 factors of production. We're going to look at labor. We're also going to look at land, and that is what we dealt with when we were talking about selecting a site. So those are matters to do with land. Then there is management, the management aspect, how you manage your labor, how you manage your spray application, how you scout, how you plant, your plant population, how you apply water. All that is the management aspects, and that one needs to be well taken care of. And then there is the aspect of capital. Many farmers usually, the moment you are recruited to grow a crop, many farmers usually go into asking about the price, and they forget about that before you get into a price is a component that is going to be dictated by other variables. So what you need to do is to ensure that you know how much is going to cost you in terms of labor, how much other inputs, because labor is also an input, fertilizer, chemicals, and seeds are going to cost you. Once you do, you work out your inputs and you add them up. And then you must have a target production per acre or per unit or per area that you're growing. That will give you the profitability, and that will help you in deciding whether you want to go into piece production or it will not make any economic sense to you. Today I'm going to demonstrate the route at which you can follow in order to get to know how much is it costing you per kg of snow peas or sugar snaps or garden peas or whichever you decide to grow. So we are going to look at the labor aspect, and the labor aspect has got various components. Once you select the land, before you start your growing, you have to decide how your blocks are going to look like. If you have a 5-acre piece of land, you're going to apportion it into, you decide whether you're going to have blocks of 1 acre, quarter acre, or half an acre. Once you decide, you have to engage a surveyor or somebody who can demarcate. There are simple gadgets that you can use to demarcate. You find the area of the land by multiplying the length and width. Once you get the area, you create the pathways because the blocks must be accessible. And then you do something we call block design. The block design will be composed of your length and your width. In this case, an acre, if we take a standard acre, which is 4,000 meters squared, an acre would be 80 meters by 50 meters. That comes to 4,000 meters squared. Then you have to determine your length, the bed length. In this case, our bed length, if we take 50 and 80, our bed length will be 50 meters, and our block will be 80 meters. So if we say that the top of the bed will be 1 meter, then in a pathway of 0.5, then if we divide 80 divided by 1.5, you'll get 53 beds. I hope my listeners are able to visualize a block that measures 80 meters length by 50 meters width. And then we divide the 80 to get the number of the beds, and the 50 becomes our length. So we have a block with 53 beds. Then we have to name that block and give it a name. For this case, we can call it A1. A1 would represent that. The reason as to why we do this is because we have to make records, and everything that we do in that block has to be recorded. And these are procedures that lead to good agricultural practice, because once you identify a block, the labor, if you send a tractor to that block, you'll send it to block A1 for plowing. If it comes to harrowing, you'll send it to record it under the block A1. And then when it comes to bed making, the labor, everything will be recorded at within that block. So by the end of harvest, we'll be able to add up the total production that we have gotten, and then all that in order to get the cost and the income that came as a result of planting that block and harvesting the same block, and then subtract all the costs, and that way we'll be able to get the profit that we made. We'll be able to know whether we made a profit or we made a loss. So good agricultural practices dictates that records have to be done as per that specific crop. The other thing when it comes to traceability, my listeners, I know you had this word traceability. If you pick from, you have to pick from a known block and record that produce as having come from that particular block, which has to have the date when it was planted, the harvesting date, the variety that was planted, and then you identify a block. When you are selling to your customer, you have to sell produce based on the blocks that produce came from, so that if somebody, the customer whom you're selling to, when it comes to packing and sending to the supermarket, your produce will go with that label and with that traceability code to the shelves of the supermarket. And in case there is a problem in terms of MRL, that problem that produce can be traced backwards from the shelves of the supermarket back to the farm. That's why it's very, very important for block design and also recording. Now, after that, you have demarcated your block, you have known the area, you have got your beds, you know the length, you know the area that is going to be occupied by your crop. Then you start your operations. You hire a tractor to make your land preparation. Basically, I've asked farmers from different areas, and I've arrived at an average of 3,000 shillings as an average charge for plowing an acre. Then you have to, when you're planting peas, you're looking for a fine till. After plowing, you want to have the block to ensure that the soil is made finer. Once you have done that, that will be at a cost of 1,500 shillings per acre. Operation number 2 will be bed making. You need to raise your beds to approximately 6 inches and level at the top to make them uniform. And here we talked about 53 beds. If you want to operate in a commercial way, you have to set targets for each and every activity in the farm, so that once you engage people, instead of you supervising and shouting about what needs to be done, you come and tell people, you demonstrate how the beds needs to be made. Then you tell that person, according to what I'm paying you per day, I would like you to, my pay is equivalent to 3 beds, for example. If you get a target of 3 beds per person, and you have 3 beds, 53 beds to be made, you see that you require 17.6 Mondays. And if the cost of one Monday, the cost of hiring one person for a day is 300, for this case, I've used 300, you use 5,300 shillings as your amount, labor amount for bed making. From bed making, you make, you can imagine the bed is now flat. You come and mark the center. Then from the left side of the center of the bed, you go 35 centimeters. And to the opposite side of the bed, you go another 35 centimeters to make 70 centimeters. From then you make furrows, 2 furrows that are parallel. And the distance between the 2 furrows should be 75 centimeters. After you have done that, you come with your fertilizer or manure if you have manure. Let's say, for example, if you're using fertilizer like DAP, you've been given a recommendation that you use 100 kilos of DAP. What you do is you take the 100 kilos of DAP, you divide by the number of beds in order to know how many kgs that you have to apply per bed. Then in this case, let's say, for example, you get 2 kilos per bed, and you are applying in 2 furrows within that bed. You divide the 2 kilos by 2 to see that you need to apply 1 kg of fertilizer per bed. So you sprinkle that 1 kilos along that furrow. Once you are done, you mix the fertilizer with the soil to homogeneity. The reason as to why you have to mix is because most of the fertilizers, as you may know, are hygroscopic. Hygroscopic means, or hygroscopic is a substance that sucks water from the atmosphere or from the surroundings. So because of the hygroscopic nature, if you place a seed next to some granules of fertilizer, after irrigation, if, let's say, for example, when you stop irrigating, and if the condition or the surrounding of the seed becomes dry and next to the fertilizer granular, the fertilizer sucks the water that is within the seed and then rendering the seed unviable. So it's always good to ensure that you are mixing to ensure that the fertilizer and the seed are not coming into contact. So to make those furrows, you do a target of 21 person would be able to do 20 furrows within an acre, and then you'll need 2.6 Mondays at 300 shillings. That comes to 795. The next operation would be manure application. If you have manure, if you don't have, you proceed to mixing. I've talked about fertilizer application, mixing. And then if you are doing drip line irrigation, in this case, the system that I'm describing is where you use drip irrigation. And depending on your source of water, it dictates whether you are going to make beds or basins. If you are doing flood irrigation, you'll have to go into basin because you'll be trapping water. You cannot make beds when you are going into flood irrigation. Beds are mainly made when you are using drip lines or you are using overhead irrigation. So you come and in this case, you install your drip lines. After installation, you come to seed placement. Remember, you've done those furrows. You applied fertilizer and mixed. Then you come to seed placement. Normally, the spacing, and spacing is very, very important in this particular case. You have to ensure that you are using 10 centimeters from seed to seed. And this one, I would advise my listeners, it should not be done by just observation. You need to look for a string, a 50-meter string, and then you mark it at intervals of 10 centimeters. So that when you place it on top of the bed, the people who are planting should be able to come and plant and drop a seed at every mark, so as to ensure that you're dropping seeds at regular intervals.
David, we seem to have lost you. David. Apologies, ladies and gentlemen, we're having a small problem with David's microphone. David. Yes, David, there's a bit of noise, but we can hear you now. David, please continue.
Of 10 centimeters. By doing so, you'll be able to use and factor that will. Hello.
Yes, David, you can hear you.
Can you hear me?
Yes, now we can hear you.
Me. Okay, what I'm saying is that we've gone into seed placing. Was that point clear about the seed spacing and plant population?
Hello, David, please just come again on the. Could you please come again on the space? We were on the spacing, and you were advising on how one can ensure that they get the right plant population using the recommended spacing, which you had described as 10 centimeters between the seed. Maybe you could pick it up from there.
Okay, yeah, thank you. Sorry for that inconvenience. Now, you use, the spacing should be 10 centimeters. And if you tell your workers to adopt the 10 centimeters and you don't give them a mechanism of how to arrive at that, then they may not be able to plant at 10 centimeters. So what you do is that you look for bed is 50 centimeters, and you look for a string that is 50 centimeters and mark it at intervals of using a felt pen at an interval of 10 centimeters, so that once you line it along the furrow, the planting furrow, then the planters should be able to drop the seeds at 10 centimeters. And that is one way of ensuring that you get the right spacing. And then eventually you'll be able to get a known, and I say known, plant population, because this is very, very important. When it comes to covering, okay, this activity, you can allocate the seed placing. One person may be able to do 5 beds, and that results to 10.6 Mondays, which dig deep into your pocket of 3,180. When it comes to covering, it's very, very important to ensure that you are not using cloths to cover. You're not burying your seeds deeper than 1 inch, because what will happen is that they may fail to germinate. Possibly, if I get time, I'll explain to why they may fail to germinate. Then that activity of covering, and this needs to be separated from planting. If you want to ensure that the job is properly done and it's efficiently done, you have to separate all the activities. You don't ask people to go and plant and cover. So they have to place the seed and then cover with the soil after the inspection. Somebody should be following up to see that the seeds are placed at the agreed intervals of 10 centimeters. If you don't take care of that, then you may end up having people covering, and some spaces could be missing seeds. So it's very, very important to ensure that covering is done after the inspection. So when it comes to after planting, you go into applying water. Water should be applied in a way that, because this seed is germinating and you want the seed to germinate, you have to irrigate up to what we call field capacity. Field capacity is that condition of the soil which is just below the saturation. If I may explain the saturation, what happens is that if you imagine a sponge, if you have a dry sponge, and you start dripping water into it, it will keep on absorbing that water up to some point. Some water will start oozing from beneath. At that point, when the water oozes, it means that sponge is already saturated with water. It has held enough water, and it cannot hold more anymore, because all the available spaces are now full of water. When it drips, that is called, in the soil or in irrigation, that is called the point of saturation, or that soil is saturated. Then you need to, at that particular point, the soil has less oxygen in it, and that condition is not ideal for the root growing. So you need to keep your soil just below the saturation point, and this is the point that is called field capacity. So you need to maintain your soil at field capacity until you get the germination. Once the germination starts, the plant is it's developing leaves, it's able to photosynthesis and make its own food. Then you need to dry off any excess water that you may have given. So you need to dry your soil and increase what you call moisture deficit in the soil. Moisture deficit is as you're reducing, you're creating a deficit of moisture in the soil. So you need to be operating at a higher moisture deficit immediately after germination. But before germination, you need to ensure that you're operating at a very low moisture deficit. So irrigation, you irrigate and you give water as per the crop growth. Things that you have to do, because you may not have the necessary gadgets for checking the moisture in the field, mainly the tensiometer or other moisture detecting gadgets, you may adopt the hand mechanism whereby, or hand technique whereby you get the soil, squeeze it. If you toss it and comes back onto your hands when it is in one lump, then you know that soil does not require water. if it disintegrate after hitting the palm, then you know that you need to add. So what you need to do to ensure is that, to know is that when the soil is dry, the plant is not able to uptake water, or it's using a lot of energy to the expense of growing. Like if, for example, if you imagine back, if you go back to the sponge that we started with, when it has water and it's at field capacity, if you want to squeeze more water from the sponge, you just have to add some little energy, and the more water would ooze. If you keep on pressing, the water would ooze until your stamina is, you don't have any stamina to squeeze extra water. But if you give that sponge this to a stronger person than you, he might be able to squeeze some more water. But that sponge still has water. So the more you reduce the water in the sponge, the more energy you need to extract water in that sponge. So when the crop is now growing at a higher moisture deficit, there is no enough water in the soil. It is using more water to extract the available, more energy to extract the water that is available from the soil in order to grow. So it is actually using that energy at the expense of either production or the growth. Now, once you understand that, you'll be able to balance your water well. And the another thing that I need to point out, when you're irrigating, you also need to ensure that you don't give more than required. If you apply or if you over irrigate, what will happen is that the water will go below the root zone, and it will also carry your soluble nutrients, especially nitrogen. So this is what is called leaching. Leaching means that the nutrients are already in the soil, but they are beyond the area that is occupied by the roots, so it's not available to your crop, and then that's when you see that some of the crop could turn yellow. So when it comes to irrigation, I have explained enough. When it comes to after germination, when the crop is at 4 weeks, you need to install the support work. Mainly you can use small thin sticks with a length of like 4 feet to 6 feet high. You plant them at an interval of 1 meter. So if you have 50 meter bed, you would see that you need about 50 of those sticks to support one row. And because you have 2 rows in a bed, then you'll need 100 sticks. And because you have 53 beds, there are 53 beds in that acre, you need 5,300 sticks for you to be able to support the crop adequately. Once you do the support, you come with a string. We normally call it the first string, which is 6 inches from the ground. You pass two strings, and then you tuck in your crop in between the 2 strings, and you ensure that you keep on monitoring the growth of the vines. You keep the vines intact and in one column up to the height that the crop will go. So in this case, you might find yourself putting up to 6 strings. And to install 1 string, you have with 1 person can do 10 beds. And the target for that, that will require 5.3 Mondays at an average cost of 300 shillings. That will be 1590, and you'll do 6 strings. So that will require, you'll spend 1590 times 6. You're going to get the total as you go down. The crop will require, under normal circumstances, you require to do 3 weedings, mainly to keep the crop clean. We know why we weed, to reduce the competition or to remove entirely the competition. Once you do that, the crop will come into picking, depending on where you are. If you are in areas within 1800 to 2000, the crop will come into picking at the 10th week or 10 weeks after planting. If you are in higher altitude, like you are in Nyandarua, which is 2,200 meters above sea level, the crop will come into picking from the 12th week or 12 weeks after planting. Picking, you normally pick pods that are in spec, depending with your market, and mainly you pick pods that are 8 centimeters to 10 centimeters. There are farmers who normally pick young pods. The younger the pod, the higher the number of pods that you require to make a kilo. If you are picking at an optimum spec of 10 centimeters, then you will have less pods per kilo, and that's how you can increase your yields by allowing the pods to come to the optimum length or maximum allowable length before it seeds. If your crop is taking longer to seed, you can actually allow that to go up to 11 centimeters, and that's how you can increase your yields. And also you have to ask your market whether it can be able to sell pods that are 11 centimeters long. If it can, and I know it is possible, because one limitation, if your pod becomes seed early, then you may be restricted. You may not even get to 10 centimeters, and you may be harvesting at 8 centimeters. And that, if you see early seeding, then it means that your crop is being subjected to a certain type of stress. Either you're not applying enough water. And it's very, very important for farmers to understand that at picking, the crop also requires that your soil remains at field capacity. So you cannot afford to have crops that are having the soils that are having. You cannot operate on a higher moisture deficit when you're harvesting, because you need to ensure that that is at the level where you optimize your production. So picking, you get pickers people to harvest your pods. You show them, you train them on how to pick, selecting the right pod. And then you also give them target, the ideal target per person. If a person picks for you 40 kilos, then that would be adequate for somebody who is being paid 300 shillings. Once you harvest, then depending on the parameters that you have been given by your customer, you grade, you remove all the pods that have got black spots in them or pepper spots. The black spots may result from a problem in the field. When it comes to the disease, I'll explain that. But the labor cost, total labor cost for growing 1 acre of snow peas is 63,542. And then if you add that to, there's also the cost of plowing, which came to 4,500. We look at the sprays or the challenges that you have to overcome when you're growing snow peas. Mainly, the main challenges when it comes to snow peas or sugar snaps or garden peas.
David, we seem to have lost you again. David, just check your audio. Hi, David. David, can you hear me? I think your audio's dropped off. David, are you able to hear me? Okay, we're having a small challenge with David's audio. Hopefully we'll have David back on board. But just as a recap, so far David's so far, David has taken us through, I think, what is very fairly comprehensive in terms of what we need to factor in from the production point of view. And most critically, for the peas family, we do not just grow them anywhere. You have to look at very specific altitude settings. That's between 1,800 meters above sea level to 2,400 meters above sea level. And there are you get it right from the beginning when you look at the issue of soil testing. And of course, this is one of the areas where we have quite a few questions. What's the frequency that one should do their soil testing and analysis on? Is it an annual exercise? Do you do it with every crop, considering that you can have several crops, several seasons in a year if you're using irrigation, as with the drip irrigation. But I think David was very categorical right in the beginning that you need to establish the nutrition status of the soil and have a feeding or fertilizer program that is then aligned to the soil status, so that you optimize the feeding for your crop. And this is right before you even get into doing the block design and land preparation. So I think as we set out to understand, these are really the factors that help us to optimize productivity. And hopefully we'll be able to get David back on board to continue with his presentation. As we check on David's connectivity, maybe just to bring in Apollo at this point in time. Apollo, I hope you're with us. Apollo, I don't know if you're able to.
Yes, Ricky, I can hear you. Kindly repeat.
Yes, I was just recounting some of the highlights from David's segment so far. And from your experience, when it comes to those matters where the block design is concerned, and doing the soil analysis and testing, and then going to those specifics. One specific that David highlighted was that the preparing the beds when it comes to actually planting the seed and then covering the seed. He was very categorical that these are two separate operations, and he was categorical that in the sense that you want to get not more than an inch of soil above the seed and not having the seed covered with clods, you treat that as a separate exercise, so that the worker or the member of staff who is doing it is not rushing. But what's your experience when it comes to how practitioners, literally go around this? Are we being too basic here, or is this something that is actually one of the failure points that you have seen over your time in agribusiness? Apollo.
Thank you, Ricky, and good afternoon, listeners. Ideally, what Ndega is referring to is in order to ensure that you have maximized on your germination. Your plant population reflects on your ultimate yield as a result of that. So it's important that the beds are well raised so as to manage drainage issues. These crops, like any other legumes, they don't like what we usually refer in technical terms. They don't like very wet feet. They like free draining soil. So the reason to raise beds is to just ensure that you're not holding up. Can you hear me, Ricky? Can you hear me, Ricky?
We're having a bit of a lag on your side. Maybe just come again, Apollo.
Did you get me to the point? Are you getting me now?
Yes, now it's very clear. Please just repeat your point once more.
Okay, what I was saying with regard to where Ndega was coming to on an aspect of raising beds and the seed cover is to ensure that you have maximized on your germination. Your germination percentage is very critical in your ultimate production. So the higher your germination percent the higher germination percent, the more it is that you at least you start building towards ultimate production.
Copy and send the comment.
The other thing is raised beds help in managing the water saturation. So you raised beds assist in ensuring you have good drainage, and you also have sufficient oxygen supply, so your crop is able to grow optimally and ensure that you have you minimize challenges related to stunting or the like. So this is what I experience across with most growers is ideally to follow the regular advice that's provided for by the crop specialist who would be occasionally visiting the farms. I hope I have answered you adequately, Ricky.
Yes, Apollo, I think you are very clear there. Maybe just for purposes of clarity, what is your experience in terms of complying to this kind of guidelines? Is it something that is very well understood, or is it constantly an area where advisors seem to have challenges with how farmers interpret this kind of guidelines, or is there maybe even a lack of uniformity in the availability of such knowledge? You know, what seems to be the gap? Because you will still hear of low productivity, yet it seems based on the explanation you were given that this is actually how you optimize and increase your productivity per unit area.
David really highlighted very well in at the beginning on the factors of production, where you are looking at land, the suitability of that land, availability of water, and then the inputs that are applied and management. Those are very critical in ensuring production is one is able to attain production. Land has to be suitable for growing. It has to be land that has had either probably pea crop grown after pea crop. It has to be land that has good organic matter level. So when you do your soil analysis, it will determine exactly the status of the land, which is the key media for production. And then water use, the availability of water is again, it will be able to guarantee crop growth in future. And then another utilization of your nutrients on the basis of coming from your crop, from your soil analysis. But the most important thing then there is management. Now you need to have the timing of when to put fertilizer, when to apply, when to irrigate, when to do the weeding. So all those practices that would be highlighted is now covered through the management practice, because you now need to ensure that your blocks have sufficient or optimal inputs to be able to support the crop growth. I think David was just heading towards the aspect of pest and disease management, which is also now the other part of this discussion. When we start looking at pests and diseases and weeds, which have the capacity now to again have economic impact on your ultimate goal. So the effective management of pests and diseases is also very crucial here, and also your block management with regards to ensuring that they are free from weeds, and it's only your crop that Ricky, you can hear me, yeah?
Yes, Apollo, I can hear you.
Yeah. those would be the very critical factors that would guarantee the optimal production. So across the various systems that are applied, and also depending on the capability of the farmers and on the advice that they get. If a farmer has access to quality agronomy advice, then they are able to maximize on production. And if the farmer has access to quality inputs, suitable land, the altitude, all that, then they will be able to definitely have optimum production and yields.
Thank you very much, Apollo. And maybe Apollo, because we kind of just waiting for David to get back on board. He dropped off the session, but as a recap from what you covered with us last week when we were talking about optimizing the market access for French beans, I remember in one remark you did mention that the broader issues are not very different. This is in terms of appreciating market requirements, especially with regards to compliance on production issues. And production, we normally cite the compliance to MRLs, which is evidence of good agricultural practice, especially on the use of pesticides. But you also mentioned social and economic, social and environmental compliance issues, which ideally are addressed by going through a certification process. And the certification such as Global Gap, because they are updated, then they onboard the most current developments with regards to market compliance. Now, for French beans, you mentioned one opportunity, which was to do more of the value packs in order to increase value instead of sending product in loose format. Maybe for peas, you would want to just highlight very briefly what are some of the specifics that need to be considered for peas going into the markets. How does that look at the moment in terms of where our markets are, and from the point of view of as the chair of FPIC, when we look at as an example the American market, is there some specific opportunity there that you might want to highlight for participants in this particular session?
We have several markets for peas, and peas is also a very it's seasonal in Kenya as a result of climatic challenges we usually face. Peas are heavily affected by wet weather. That's when our potential we are literally constrained to sell our peas. Then we have seen a reduction on the overall exports of peas through the years. One related to again competition that is coming from Latin America, Guatemala, Peru, and then in Africa we have Zimbabwe, Egypt, Zambia, which have recently just started opening up a lot. They all have their seasonality in production. Now, unlike French beans, peas in Kenya would be the most critical periods are when we don't face challenges from, especially from the southern African countries, Zimbabwe and Zambia, and when there's no crop coming from Egypt. So we have a window to supply, which is usually between September, October, November, and a bit up to December. Then January, we are not able to compete effectively. The South African countries have serious capacity on scale. They produce in a very large scale acreages, unlike us here, that our production system is still very fragmented, relying on lots of smallholder producers. If you look at the Zimbabwe model, they have large farms, so they're able to take advantage of shipments by sea. And again, that's a similar scenario from the South American countries who are able to consolidate production and then push it through by sea. Consolidation here is very key because, as I mentioned earlier in the other French beans, the French beans presentation, everything relies on costs, on the cost along the supply chain, and the biggest cost here right now is related in the cost of freight. It would cost you between $1, $1.80, sometimes the COVID times up to $2.50, even $3 per kilo to ship by air. Yet by sea, if it is containerized, this would be going up to around 30 US cents per kilo. Now, our challenge here is how are we able to consolidate production? In looking at that, now we have very fragmented production systems, and we are not able to consolidate production accordingly. These are the kind of things that we may need to look at. The requirements now, regulatory aspects for peace are similar to requirements for beans, although peas are not subjected to the stringent border tests, and unlike beans that are for every consignment 10% has to be tested. The piece is different, but that does not mean that our product is never tested. Especially in Europe, which has very stringent food safety systems and the regulatory approach. So this is where complying to regulation is very key, and our authorities have highlighted regulations that would be required for one to be able to comply to this, and these are related to food safety, environment, and social aspects that would also be demanded by our markets, and that's what for a grower or any exporter, those would be the key driving factors in future, especially coming from 2021, that would have to be enforced in order to play a part in the, whether it is in the horticulture export segment. If one is doing that to Europe, we have opportunities to do that into the Middle East and a bit of the Far East. But the US market is not yet open for us because we need, from the test risk analysis, we have to subject products through very stringent management aspects. And the only product that Kenya can ship into the US as of now are probably the shelled peas or garden peas, as we were told earlier. I think I have tried to highlight a bit of that, Ricky. Thanks.
Thank you so much, Apollo. Maybe just one last one before we go back to David. I think it's very interesting what you've pointed out about the competitive advantage for the Southern African countries, where you say they can consolidate and get sea freight, as opposed to a scenario where we are relying on air freight. What would be, how do we change that particular narrative? Because for the volumes that we need in order to hit for the volumes that we need in order to move to sea freight, as an example, within our competitive window that I think you mentioned that as September to October, what is it that could be a game changer that, you know, we've got a diverse crowd of participants here, and for those ones already in the peas value chain, what is it that they are not doing that could actually make this drastic change in terms of shipping costs just by moving to sea freight and moving, you know, having less reliance on air freight? Apollo, I hope you got that question.
Yes, indeed. It's a matter of consolidation and ensuring that we are able to produce sufficiently to scale and ensure that we have more or less one-off production systems, so that if I have, we have to synchronize production in a way that if I'm working with producers or if I'm working with farmers, they literally have to plant at the same time and handle operations within literally within on a day-to-day basis at a same time, and ensure that we are able to have the harvesting done around the same time, so that product is harvested, graded, and stored. If I'm doing sea freight, for example, a container would carry a 40-foot container. It has capacity to carry about 30 tons of product, and then a 20-foot container might do around 15 tons. So I need to ensure that on the day of the harvest, I have the sufficient scale and the volumes that I'm able to fill up my container and store it accordingly, so that it is within that very specific window I'm able to undertake the processing, the packing, and the storage, and therefore I'm able to ship my product when it is still, all of it has been harvested within probably 2 days of harvest. That's the sort of intensiveness that is required to be able to handle sea freight. If we scatter our harvest and the similar way we do during for air freight, we are not able to make it in that regard, because our containers again are what we call controlled atmosphere containers. So they have some element of gaseous exchange, carbon dioxide and oxygen exchanges within this container that we have to maintain prior to the expiry of this gases exchange. And so it is important that the synchronization bit is at the top of the game. Thanks, Ricky.
Thank you very much. Thank you very much, Apple. I think that was very, very clear. David, welcome back. When we lost you, we talked a bit about some of the market access issues, and I think you managed to rejoin us just as we were getting that input from Apollo War. David, I think we have about 8 minutes to go in this particular session. I know we haven't covered all the production issues, and we should be in a position to pick this up with the next session. But as you kind of pick up and recap where you had gotten us to, where we were looking at the you actually covering issues around the harvesting. We do have a question that I would want to throw back. One of our participants asked for water used for peas, and also can it do well in a highly humid area? Those are some questions that are coming through. Maybe David, you might just want to touch on those two as we continue and have a bit more input on you around harvesting, and hopefully with a
Hello, Ricky, I lost you. Hello, Ricky, I didn't get your question clearly. Could you please come again? I seem to be having a problem.
Sorry, David. So the question was on. Yes, David, there was a bit of a problem on our side as well. But did you get my question, David?
No, I didn't get your question, Ricky. Could you please come again?
Okay, so we have a question from one of our participants who's asked about the total coliform Tc and Ph. What is the recommendation? What is the guideline for that? And the second question they're asking is, can it do well in a highly humid area?
I'm getting you in a scattered manner. I've heard whether peas can do well in the humid area. Is that the question?
Yes, David, that's the
Hello?
question. That's the question, and the other one
There was
was
a first question that I didn't get.
the first question was for the what is the guideline for total coliform and pH for water used for peas? You had mentioned the total, the TC count and pH. So one of our audience members is asking, what is the guideline for that?
Mainly the total coliform, when it comes to coliform and pH, once you send yourself to the analysis. The analysis comes with a guideline, and the pH of the water normally ranges from 7 to 7.5. That's ideal. And also may go up to 6.8. That's ideal pH. Coliform counts, they should not be more than 2, at a count of 2. But the guideline is actually stipulated well in the water analysis report, and that would be more dependable. When it comes to the question about whether peas can do well in high humid area, this mainly could be high humid areas, could be low altitude areas with either near to water source, like coastal regions, high humidity areas, and peas will not do well there. You need to be in cool areas above 18 meters above sea level. 1800 meters above sea level to 2000, 2500. These are areas like Kinagop, Timboroa area, and many parts of Kenya Highlands. Thank you.
Thanks, David. So I think the last point was you had kind of taken us right to harvesting, and you are covering the aspects around the harvesting in terms of optimizing production. We have about 8 minutes on the clock, but I believe within the time frame you would be able to cover and maybe then round off with a gross margin as per what you were explaining earlier. So maybe you'd want to just pick it up from there.
Wow, it means that you guys didn't hear most of what I said. I was talking to myself then. Okay, no problem. Sorry for that inconvenience. If I could pick from harvesting, what I was saying is that growers may be able to do all other aspects done properly. Like one may be able to spray properly or efficiently, you feed properly. But when it comes to harvesting, you may find that growers are not training their pickers well. And pickers could be picking pots that are below 8 centimeters. A pot that is below 8 centimeters is an underspec, and you need to be picking between 8 and 10 centimeters, which are ideal. And if you could train your pickers to pick at 10 centimeters, you would end up maximizing your yield, because you are picking the 2 centimeters. If you look at the 2 centimeters multiplied by the number of pods that are required to make a kilo, which is like 320 pods, 320 centimeters, that's quite a number of pods. And you can see, if you are picking at 8 centimeters, if one farmer is picking at 8 centimeters and another one at 10 centimeters, that can make a very big difference. And then I went after that. So the issue of the spec is very, very important, and the growers needs to ensure that they are picking at the right spec. Then I went to the issue of the gross margin analysis, where I said I compared. In my gross margin analysis, I'm comparing a farmer who picks 3 tons and the one who picks 4 tons from the same acre. The difference here will be the treatment. You can have 2 farmers doing this, applying the same amount of fertilizer, pesticides, and irrigation, doing all other factors being the same or being constant. But you find that when it comes to the yields, there could be yield differentiation depending on the management. So if you look at the farmer, assuming farmer A produces 3 tons, and in the second scenario where farmer B produces 4 tons, and we take an average price of 80 shillings per kilo, at the end of the day, farmer A will make a gross income of 240,000, whereas the farmer B will make a gross income of 320,000. If you look at, if I go down the cost of leasing land, I'm giving it 6,000 shillings per acre. Cost of seeds 7,500. Plowing 4,500. That is at 3,000 shillings for plowing and 15 for harrowing. Labor 53,000. But the labor aspect changes. The farmer who picks 4 tons, his labor amount will be more than by a smaller margin because of the extra harvesting, extra picking, the harvesting, the extra kgs. Chemicals, the 2 farmers are using that 1,000. Fertilizers, it's 16,800. Irrigation is costing 20,000, and total cost for farmer A is 139,168, whereas for farmer B is 149,000. If you add 10% of indirect cost, you'll see that farmer A will end up spending 153,000, while farmer B will spend 164,000. The bottom line, or the net profit for farmer A, is 86,000, whereas for farmer B is 155,000. In a nutshell, what I'm saying is that it is the cost per kilo, I mean the yields that you get per unit area, that will give you a competitive edge against any competition, and that's how you'll be able to manage to survive in this business. You have to ensure at every given time that you are increasing you are hitting your target yields per hectare or per acre or per the unit area that you are carrying out your production activities on. Thank you.
Thanks, David. I believe that's very, very comprehensive from you up until that point, and we are trying to see if there are any questions from our listeners on the chat or Q&A. At the moment, there are none, but participants, if you have any questions for David or Apollo, this is your time. Of course, even as you raise any questions, we encourage you to take a moment and also fill out the survey. We've shared a link on the chat box with a survey for this particular series. But as we do that, David, just recapping this last point you've mentioned, and I think this is very, very strategic. If I got you right, you are looking at a net income of 86,000 for farmer A versus 155,000 for farmer B. Is that correct?
Yes, that's correct.
And David, this is arising from the precision at the time of harvest, because from your calculations, all the other costs were pretty uniform. So this is based on the precision during the harvesting period, which ultimately affects the production per unit area. Is that correct?
Yeah, it's partly because of the precision in harvesting, and also the main deviation that causes the difference in production could be as a result of different management aspects, whereby the 2 farmers we may use same cost, but you see that the farmer who is more effective possibly would have would be doing his operations in a timely manner, like irrigating on when the crop needs that irrigation, and spraying when the crop is supposed to be irrigated. So he is not incurring any losses as far as inefficiencies are concerned, and that's what would contribute to the 4 tons, and the other one produces 3 tons. In this aspect, you find that the only cost variation comes into the cost of picking the higher yield, but that will be cancelled by the fact that he is selling a ton extra than the farmer who produces 3 tons. So it's very, very important for the farmer, and especially for the 300 the farmer who got the 3 tons. Possibly he did not follow the spacing properly, and all those things. Covering was not properly done, which could result to low germination or something like that. So I did these 2 comparisons so as to show that the importance of sticking to the ball and keeping the eyes on the ball to make sure that the target yields are achieved. Thank you.
Thank you very much, David. And yes, I think Angela, who's just posed a question, this is a question that David was answering just now. Unfortunately, we had a small technical problem, and David was not able to share his screen. However, his presentation will be made available. As at now, if you are able to visit the SOCAA website, that is www.SOCAA SOCAA.or.ke, you would be able to access presentations even from previous sessions and links to recordings which are actually on YouTube channel as we speak. So David has just finished his run through on production, and just as a means of recap as we wind up and still taking any questions if there are. The main essence of what he has said is attention to detail on the specific steps within the production period that then ensure that when it comes to your productivity per unit area, you're able to optimize. And this is how you then increase the value for your business, because you're not looking at cutting down the costs. You want to use the inputs as required, but you want to optimize your productivity by ensuring that the different steps within the production process are followed to the latter. David, there was a question earlier on, maybe just to bring this back to you, even as we try and see if there are any other questions or answers. With regards to soil testing and analysis, what is the recommendation, given that in any particular year you would have several cropping cycles, so is there some guideline there, because everything starts with the analysis and how you adopt your nutrition in order to ensure the crop gets optimal nutrition. So maybe you might want to say something towards that, even as we look at any other questions, or which there are none. So actually, David, as you answer that, maybe you would also make your closing remarks, and then we can have closing remarks from Apollo as well for today's session.
Thank you, Ricky. In terms of soil analysis, and this is an area whereby most of the farmers are unable to understand, and in order to make it clear, I would ask somebody to imagine soil as a fat bank account. Let's say, for example, imagine a son whose dad has parted and has given him a fat bank account. And all what this son is doing is to withdraw the money, and he's not banking, he's not depositing, he's just withdrawing. At some point, the account will be depleted, however much the amount of money or the deposit at the beginning was. So soil has its own reserve of nutrients. And the soil analysis actually aims at finding out among the reserve what quantities are available and what can be utilized by the crop. Then different crops removes certain quantities of nutrients, NPK, in terms of nitrogen, phosphorus, and potassium. Each crop has got its own specific quantities that it removes from the soil. So the moment when you have the crop in question and you have the soil analysis, the agronomist will be able to recommend what is required in terms of fertilizer program based on what that crop removes from the soil and what is available from the soil reserve. I hope that one is clear. In my parting shot or parting remark is that in this business of farming, and I usually say that farming is a game, and every game has got its own set of rules. If you want to play any game, the most important thing that, or the best thing that you may do, is to ensure that you learn the rules of the game. You cannot play football effectively if you don't understand the rules. You cannot even coach. You can only observe. And that's why if you are observing a game of football, you will see the mistake that the person in the field is making. But if you are given the ball yourself, you will not be able to rectify. You might end up making more mistakes. So once you get to learn the rules of the game, then you perfect the outcome of that game. So if you want to go into growing and if you want to go into farming, just ensure that you get attached to those who can train you. Just like if you have a toothache, the best person to consult is a doctor, but not a plumber. So get to know who you are consulting and get to ensure that your consultants are people who are affiliated to an organization such as SOCAA. SOCAA has a wealth of people who are qualified. Person like Apollo, he is highly qualified with very good credentials and on advising. So ensure that you get to know who is advising you, and don't go for a plumber when the problem is the teeth. Thank you.
Thank you very much, David. I think that was very good advice there. Apollo, maybe your closing remarks as we wind up for today.
Yeah, thanks, Ricky. And again, thank you, David, for a very elaborate and detailed presentation on peace. I think that was on to the point. I would just like to add a bit with regard to that. It's that, most of the peas are grown by smallholders. So it's important that one becomes part of a grower group in order to be able to take advantage of economies of scale. One acre might not be very sellable, but 1 acre times 80 is 80 acres. That is attractive to buyers. And for exporters out there, it's important that you're also able to take advantage of working with farmers who are involved in a group setup. That way, you are able to then monitor and follow up production accordingly. So these are the key drivers to trade in this. These are the key drivers of trade in this business, and I would like to support all the sentiments that there is money in horticulture if we play our cards well. Thank you very much.
Thank you very much, Apollo Owor, a seasoned agribusiness advisor. He introduced himself as an agripreneur in the last session, and we've seen his sound advice. And David, of course, very passionate about agribusiness. He's described this as a game, and you have to understand the rules in order to effectively play and win in the field. I think they have done a very wonderful job in terms of just taking us through the key steps towards success for the production and market access for the peas value chain. We have some challenges to us about consolidating our production and being very precise in terms of being able to put the right volumes out and then make use of opportunities such as sea freight. And I think for us, the takeaway there is that we need to consolidate our business approach through the BMOs that exist, as opposed to going it alone. That way we can actually get to the right volumes and then bring down the costs. The differential was very, very clear, up to $3 per kilo on air freight versus a tenth of that, 30 cents per kilo on sea freight. I think that is a big challenge to anyone who is in this particular area of agribusiness. And from David, really, it's not about cutting back your input requirement or costs. It is about being very precise on each and every step in the production process so that you can optimize and get the intended or recommended productivity per unit area, which then in turn gives you a good return irrespective of the prevailing prices in the market. I think these are solid remarks. And again, as we said when we started this session, the objective is really to help us as participants in agribusiness who are either involved already in producing these particular commodities or trying to establish themselves, to understand what is it that will actually give you that competitive edge. So we want to thank our partners, SOCAA-SheTrades Commonwealth, who have made it their mission to increase the participation and sustainability of women in agribusiness, and SOCAA, the Society of Crop Agribusiness Advisors, who provide a platform for crop agribusiness advisors. Thank you very much for being with us this afternoon. We have gone slightly over the time that we had set for this, but we thank you for your indulgence. And once again, the presentations and even this recording will be available. We shall share them on our various platforms. So please just visit either the SOCAA Twitter handle or Facebook page, or even the SOCAA website, and you will have access to the material that has been shared this afternoon. So thank you, everyone. We wish you a good afternoon and evening where you are. And we look forward to hosting you once again next Wednesday, as we move now to start exploring the issues around optimizing production for avocado value chain. Thank you once again, and have a good evening.